Hello, so let me show you a quick workflow on how you can use the Labelbox platform to improve a retrieval process. So typically how it works is the user asks a question, it's going to go through this custom chatbot, and we're going to use the retrieval method to look through your internal corpus of documents so that you can retrieve the top few chunks, and that chunk is going to be added as context to your LLM so that you can generate a response. So how we're going to use Labelbox is we're going to fine tune a re-ranker model. And a re-ranker model can help improve your retrieval performance because in many studies, it's shown that contextual information might not belong in the top 5 results of your initial retrieval algorithm. It could be stuck in the lower levels of relevance. So we're going to use a human loop process, evaluate each chunk of text as it pertains to the search query. And then we're going to use that to fine tune this re-ranking model so that it can take context from retrieval documents far below and add that as context to formulate maybe a better response. So let me show you how this works. So I'm going to start off by running this pre-processing notebook and just show you a baseline experiment for retrieval. So I'm just going to load in some documents here. And as you can see here, I have a consistent transformer model to embed my documents into vector embeddings. So we're going to keep this consistent for both experiments. And for the sake of our example today, we're going to upload a PDF containing all of the NFL rules. So all the NFL referees probably has to be familiar with this PDF. And it's quite extensive. As you can see here, the rulebook consists of 245 pages, and we're going to formulate our splitting strategy here. Right? So we're going to define a chunk size, and in many retrieval use cases, right, this is another method or another set of parameters that you can tune to improve your retrieval. We'll save it as a vector index. You can save it into your vector DB as well, and we can test this out to see how well it performs. Right, so here's a sample query that I might want to ask a chatbot. And you can see here that the most relevant result, it consists of this chunk of text right here. So let's go ahead and evaluate the baseline performance. Retrieval with no re-ranking for our NFL documents with this set of embedding model and baseline LLM model. So here's our list of queries that we want to ask the chatbot. And because of token limitations for many LLM models, right, we're just going to get the top 2 documents, and we're going to use the top 2 documents as context for our LLM model. So here's the model name. We got it off Hugging Face, and we can use those top 2 results as context for this model. So here's the question, sample question, and here's the results based off of the context. And now we can just run it across all of our list of questions and get a corresponding response based off of the context. We'll go ahead and save this to a CSV file, which we can use later on. Okay, so that's our baseline experiment. Let's go ahead and move on to creating the training data set for fine-tuning our re-ranker model. So here, let's go ahead and extract the top 5 chunks for each query within our initial data set. And these response chunks are going to be the data that we're going to send over to the Labelbox platform for that human-in-the-loop review process. Okay, so to send it to Labelbox, let's go ahead and import the Labelbox SDK. Let's go ahead and format our pandas data frame a little bit. And let's go ahead and create that asset object where we can submit all of our text, queries, and response chunks into the Labelbox platform as a task. So if there's no errors, as you can see here, let's head over to the Labelbox platform. So I'm in the Labelbox catalog, and as you can see here, my job was successful. We have 354 of our user queries and the top 5 most relevant chunks, all loaded in as text assets within the Labelbox platform. So this is going to be that platform where we can do human-in-the-loop response. So before moving further, it might make sense to show you what a re-ranker model looks like and what types of response it accepts to fine-tune a model. So I'll head over to this Cohere website, and you can see here we need to upload our data in a JSON-L format, JSON line format, and this is very relevant to our ontology, right? So for each chunk, we're going to have to flag it as relevant or not relevant. So that's all we need. The ontology is fairly simple, 2 options for each chunk of text. So here, I'm back in my Labelbox platform, and before I create that annotation project with the ontology that I just learned, let's actually use ModelFoundry to take a first pass. We know that your expert annotators are trained for efficiency and accuracy, but let's take some weight off their shoulders by generating a set of pre-labels that they can rely on. So we'll select all of the data within this dataset, and we'll click on the Predict with Foundry option. And as you can see here, we give you different options for passing your data through an initial set of foundation models. So you can choose any of the foundation models here so that I can generate that pre-label for you based off of your prompt. So if that doesn't make sense, let me show you how this works. So here I have a OpenAI GPT-4 model that I have created. As you can see here, I uploaded the ontology, right? 2 responses for each chunk. And for each chunk here, right, I have developed the prompt to tell us whether the chunk is relevant to the query or not, or if it's negative, if it doesn't contain information that I need to answer a specific query. So by formulating this prompt with the ontology, I can now generate some previews from my OpenAI model. After a few seconds, the previews has been generated, right? So now for each query and chunk pairs, we can now get pre-labels for how OpenAI determines whether each chunk is not relevant or relevant to this specific question that the user may be asking. So if I'm satisfied with this response, I can now submit the job and apply these classifications throughout my entire data set. So now my annotators have some pre-labels to work with. Once the model job is finished, I can now click on each row within my dataset back in the catalog and determine and check out the predictions. Right, so now I have pre-labels for every chunk within each row within my dataset. And once I send this over to my annotators, they're going to save a lot of time. So let me show you how to set up that annotation project. So let's set that up. So we'll head over to the annotate component of the Labelbox platform. And let's go ahead and create a new project. We're working with text, so we'll select the text modality. We'll give this a name, maybe demo with today's date. And let's go ahead and confirm the project. So now all we need to do to finalize the configuration is to add the data and set up the ontology and labeling experience. Let's set the ontology up first. So we'll head over to settings, edit the standard labeling editor. And as you can see here, we can choose the ontology that we want to use. In our case, we want the retrieval ontology here. This is going to give you a preview of what the ontology looks like. What are the guardrails as to how your annotators can annotate each data row. And as you can see here, we have 5 global classifications, right? 1 for each chunk. And based off the guideline that Cohere has provided us earlier, right, we want 2 options, whether that's relevant or not relevant for each retrieved chunk. So this is that human in the loop process that we have to find. Let's save it. And all we need to do now is to add the data. So we'll head over to catalog. We'll choose all the data rows within this data set that we uploaded earlier, select all of them, and we'll add it to this annotation project. We'll choose the project that we have just created. We want to include the model predictions from our GPT-4 model to give our annotators a head start. And we can set a priority. Once all this has been configured, let's go ahead and submit this list of data rows to our annotation project as a job. So now we can head over back into our annotation project, confirm that the data rows has indeed been added. You can see here we have a data row. And now our expert team of annotators that are familiar with the rules of the NFL can start the labeling process. And because we added pre-labels into our Labelbox workflow, right, you can see here that the results of the GPT-4 model has been automatically populated into the labeling editor. So as an annotator, this is going to save me a lot of time. Instead of starting from scratch, I can simply review and change the results of each answer of these pre-labels. I can use these hotkeys to speed up my labeling task and hit submit to move on to the next data row. And once my labeling operation is finished, that human-in-the-loop process is finished, let's go ahead and export all of our annotations and ground truth data to fine-tune that model. And if you remember earlier, right, we're going to need it in a JSON line format. So if we head over to the export section of our labeling project, it gives us the code that we need to export all of our ground truth data. So let me show you how that works. So now we can go ahead and paste that chunk of code with our project ID, initialize the Labelbox client, and now we can just go ahead and break down the JSON and convert our labels into a data frame format for easier visualization. We can also save as a CSV and convert it into a JSON line format that open source libraries or Cohere uses to fine-tune a re-ranking model. What one line of that JSON looks like. You got the query, your positive examples as a list, and your negative examples as a list. We'll write this to a JSON line file format, and we're ready to start the re-ranking fine-tuning process. So we'll head over to the next notebook, and the first step is to select the model. So you can use Cohere, or in this case, we're using an open source model that we found on Hugging Face. And from the documentation of this model, right, we can pass in some sample query and response pairs, right? So, two of the same queries and two different answers, and it's going to tell us which one is more relevant. So the lower the score, the less relevant the response is. So that's how this model works. And let's go ahead and feed in our JSON line format containing our labels to fine-tune this re-ranker model. As you can see here from the log files, across a few epochs, our loss starts to decrease and our learning rate starts to decrease as well. And now we can test our model on some sample data, right? So here's a quick query. How many points does a touchdown worth under some conditions? And here's all the positive and negative examples. And from our human-in-the-loop process, right, we can see here that we have provided this data row 3 positive examples and 2 negative examples. So the key thing to note here is what matters is the relative order of the scores, not the absolute value. So as we can expect, there is 3 positive examples, right? They all have relatively high values, with 2 negative examples with very low values. Right? This shows us that our model is fine-tuned to the examples that we provided. So the next step is fairly simple. We want to replicate our experiment, the same LLMs, the same embedding models, to re-rank all of our query response pairs with this re-ranker model that we have fine-tuned. Okay, so we're going to load in our queries again with all of the labels and responses. And we can go ahead and take a look at the score distributions for relevant versus non-relevant labels. And as you can see here, the non-relevant ones are typically negative, and the histogram of relevant ones are typically positive and higher. Okay, so let's put it all together. We'll use the re-ranking method. We'll retrieve the top 20 documents now for each specific query. And then we'll use our fine-tuned re-ranking model to get the top 2 results as context for the same LLM model that we're going to use. Okay, so we'll initialize that same embedding model from Hugging Face. Now we're going to retrieve the top 20 responses for each query. So now for each query, we got a list of 20 responses. And now we're going to use that fine-tuned re-ranker model to go ahead and only extract the top 2. So in this case, let's go ahead and bring in our LLM model, which is the same baseline model as well. And for each query, we can now feed in the top context from the result of our fine-tuned re-ranker model. We'll save this as a CSV file, and then we can just do a simple inner join to compare the responses for each question of the updated response, right, from our fine-tuned re-ranker model in our initial response. And just taking a look at initial pass of our responses, you can see here that some responses are better, right? This re-ranker method is certainly not a magic bullet. Some results are definitely better. Others are a little bit worse. But as you can see overall, this re-ranker method does work to match the pattern of your data. It uses the human loop process to incorporate real human expertise so that you can get a better answer, such as this one below here, right? How many feet in bounds to constitute a catch in the NFL? Right? Everyone who watches NFL knows that is 2 feet, not 20. So hopefully this video shows you how you can use the Labelbox platform to incorporate a human loop process to fine-tune a re-ranker model as part of your retrieval process. While this is not a magic bullet, this is definitely a technique which can help improve your customized chatbots in other retrieval processes. Thanks.